Welcome to this video on vector magnitude and unit vectors. The prior knowledge for this video would be basic trigs and component form of a vector. To look at magnitude, let's talk about an example. We got Robo who has traveled 8 meters west and then turned around and then traveled 6 meters north. And we want to determine the magnitude of Robo's displacements. By definition, magnitude of a displacement is the shortest distance from the starting position to the end position. Let's look at how this looks like using vectors. So we start off by drawing a coordinate system. We'll label east as positive x and north as positive y direction, and therefore our displacement is -8, indicating 8 meters west instead of east. The negative goes to west, and 6 meters north, so we keep it as positive because that's our positive direction. We draw it out. 8 meters west is to the left, 6 meters north is to the north or up, and our hypotenuse will show our distance there. That's the shortest distance from the starting position to the very end position. So since the 8 was going to the west and 6 was going north, the angle between them is 90 degrees. So to find that distance value, we can just use Pythagorean theorem. So distance squared is equal to 6 squared plus 8 squared, and we take the square root of that and we get distance is equal to 10 meters, and distance has to be positive, so we have to keep the positive value. So in general, whenever we want to find the magnitude of vector, given that vector v is equal to has x component vx and y component vy, to find the magnitude we take the square root of vx squared plus vy squared, and that's just because the magnitude is the hypotenuse of the triangle formed from the two components, and therefore we have to use the Pythagorean theorem. The next concept that we want to discuss is unit vectors, and unit vectors are any vectors that have magnitude or length of 1, and they're mostly used to show directions, and we'll deep into a lot more detail in this in future lessons. Let's now talk about base unit vectors, and there are 3 major base unit vectors, and today we're going to discuss 2 of them. Vector I, sometimes shown as I with an arrow for vector I, or I with a hat, is vector 1, 0. That means it moves 1 unit in the x direction and 0 unit in the y direction. And vector j, or j with a hat, is vector 0, 1, which means it moves 0 in the x direction and 1 in the y direction. So now this is going to help us write vectors in a new format. So let's imagine we have vector a, it moves 4 to the right, and so we can write this as 4 multiplied by vector I, and it goes up by 3 units, so we can write that as 3 multiplied by vector j. So vector a has components 4 and 3, 4 in x, 3 in y, and we can rewrite that as 4 multiplied by unit vector I, because that's going in the x direction, and 3 times unit vector j, because that's going in the y direction. The first way of writing this is the component form, and the second way is called the unit vector form. This way of writing vectors will be very helpful when we're adding and subtracting different vectors, so we'll see that in future lessons. In our next example, we're going to have this vector, and for this vector we have to move 2 to the left from the origin. Since vector I moves to the right, this means it's -2i because it's going in the opposite direction, and it's going down by 4, and since vector j is going up, this means it's -4j. Note that we can also start from the origin and go the opposite way, but we still get -4j and -2i for our vectors. So in this case, vector b will have 2 components, x component of -2 and y component of -4, and we can rewrite this as -2 times unit vector I minus 4 times unit vector j. In general, if we had a point in a coordinate system, and if we were to create a vector that originates from the origin and it terminates at point P, then that vector will have an x component which moves to the right by x units, and it goes up or down by y units. So we can rewrite this as the point P with coordinates of x and y has position vector OP, which equals to xy, or x times unit vector I plus y times unit vectors j. So in this lesson, we've talked about magnitude of the vector, unit vectors, and base unit vectors, and how to write vectors between component form and unit vector form. Now we're going to look at 3 examples. In the first example, we want to determine the unit vector form for the following. Vector A is 3, 8, B is -2, 3, and C is -2, -2. Well, we know that the x component of vector A is 3 and the y component is 8, so to rewrite this, we will write it as 3 times unit vector I plus 8 times unit vector j. Similarly, for vector B, it's -2 times unit vector I and +3 times unit vector j. And finally, for vector C, we got -2 times unit vector I because that's the x component, and -2 times unit vector j because that is the y component. Let's look at a magnitude question. We want to determine the magnitude of vector A, which is 3 times unit vector I minus 4 times unit vector j. We know the components of this vector are 3 to the x direction and -4 in the y direction. Therefore, the magnitude of the vector is square root of 3 squared plus -4 squared. And this will give us square root of 25, which is equal to 5, and therefore the magnitude of the vector is 5 units. Last question, we want to determine the value of k given that the vector represented by components -1/4 and k is a unit vector. The first step of solving this question is to recognize that a unit vector has a magnitude or length of 1. Therefore, we can write the magnitude equation. We know that the two components of this is -1/4 and k. So square root of -1/4 squared plus k squared should equal to 1. And we can square both sides. And solving this and rearranging for k, we get k squared is equal to 15/16. And if we were to take the square root of this value, we would get that the value of k could be positive or negative square root of 15 over square root of 16, or positive plus or minus square root of 15 over 4 units, being our final value. I have prepared 3 questions for you folks to try out, so please try these out and I will try my best to post up the full solutions to them at some point. I hope that this video has helped you understand a little bit how to calculate a magnitude of a vector and figure out what unit vectors are. We will get into much more detail about them in future lessons, and thank you for watching.